In today's video, we are going to build on what we learned in the last video and explore functions in more depth. In today's video, we are going to focus on creating what is called the shift cipher. For our purposes, the shift cipher will only work with the characters A to Z lowercase. Furthermore, we will be able to specify a shift value or shift amount, which is how much we want to do the shift. For instance, if I have B, C, D, E with a shift of 0, we get the same thing again. But with a shift of 1, all the characters get shifted to the left once. And in the last example, if we have X, Y, Z with a shift of 1, you can see it does a wraparound and Z becomes A. So let's look at how to implement this, and let's get started. To begin writing our shift cipher, I have put two function definitions down. The first is going to be encrypt, which will encrypt our string with a default shift of 3. And decrypt will decrypt our encrypted message, which I denote by the character E, and also with a shift of 3. We need to make sure our shifts line up, otherwise we won't be able to decrypt properly. So for instance, let's encrypt hello world, and we'll leave it as shift of 3. Right now it is not returning anything, so we need to write our function. So I'm going to say our encrypted string is going to be empty for now, and all we're going to do is we're going to loop through this string, find its characters, find where this character occurs in our alphabet, find its index, and then do the shift, and then grab that shifted character, and then put that in our encrypted string. So for a character, I'll call it C, in our string S, then we want to get the index of C in alpha. So alpha dot index of C. Now we want the shifted index, which I'm going to say is just index plus our shift. However, since we want the wraparound to occur, we want to do a mod by whatever the length of alpha is, which so happens to be of length 26, because there are 26 characters. And now we want to append the character of the shifted index. So encrypted string plus equals alpha of shifted index. And once that's done, we can return our encrypted string. So if I run this, hello world turns into this mess. However, with a shift of 0, it shouldn't do anything. And with a shift of 1, we can correctly observe that this is correct. So if we have H, then the next character over from H is an I. So that's why we have an I in the first position. And E is over here, and F is the character with a shift of 1. Notice that if I have a shift of 26, then we also get hello world back again. In fact, this is true for any multiple of 26. Now let's do the same thing, but let's decrypt it this time. This time we are getting the encrypted string as input. I want to get the decrypted string as output. So we're going to follow a very similar procedure. So for C in S, get the index of this character, And now we also want to compute the shifted index, except this time we don't want to add because we added when we encrypted. So the opposite of adding is subtraction. So we want to subtract. And now we get decrypted string plus equals alpha at our new shifted index. And we want to return the decrypted string. Perfect. Now let's run this again, and it says I have unknown character s. That's because we pass an e instead. There we go. So if I have this for hello world, if I print decrypt of that, we should get hello world back. And we do. So for any sequence of characters from A to Z, we should always get the original string back if we do decrypt, encrypt of some arbitrary string. Maybe like AAA, BBB, CCC, and a bunch of Zs just for fun. And we get the same thing back again. So we know that our encryption and decryption work perfectly. In this video, we looked at how to implement the shift cipher. In the next video, we're going to start looking at function recursion. See you next time.